We're building our understanding of how to calculate derivatives of various kinds. So we'd like to be able to find the derivative of any function that we happen to encounter, so we can get the slope of that tangent line and know the rate of change of the function. And so in this video, we'll take the product and the quotient rule so that we can understand what happens when you have functions that are multiplied together or divided. So that's our basic question here today. I think this will be a relatively short video. We'll do one example of each, one with multiplication of two functions and one with division of two functions. So first, the product rule. What happens when you have the product of two functions? Well, first, those functions themselves need to be differentiable. So if you have a function that you can't take its derivative of, everything we've looked at so far is differentiable. If you can't take the derivative of one of the functions, you can't take the derivative of their product. So let's assume that you can take the derivative of both of the two functions, and let's call those functions f and g. Then, what is the rule for differentiating the product? So we have the derivative operation and then the product of the two functions, and those two functions are in the parentheses. So you're taking the derivative of this product. Well, to do that, you take the derivative of each function and you multiply it by the other. So derivative of f times g, and then you add the derivative of g times f. So that's all there is to the product rule. If you're taking the derivative of a product, you take the derivative of the first times the second, and then derivative of the second times the first. Okay, so this will make more sense when you have some examples under your belt. And so I've picked a function here, x squared times x cubed. And I've done that so that we can do an example where we know what the result should be. I could simplify this. I could call this x to the fifth, right? And the derivative of x to the fifth, we could just use the power rule. And you'd bring down the 5, subtract 1, so it would be 5x to the fourth. So skipping ahead to the answer, we know what we should be getting is 5x to the fourth. But I want to do this using the product rule so that we can illustrate what this means. So this will be our function f, and this will be our function g. So we take the derivative of f times g, derivative of g times f. Let me go to my other laser pointer. Okay, so derivative of this function f, x squared becomes 2x, and then x cubed. So 2x times x cubed. Derivative of x cubed becomes 3x squared times x squared. And now it's just a matter of simplifying the result. 2x times x cubed is 2x to the fourth. 3x squared times x squared is 3x to the fourth. 3 plus 2 is 5, so we get the answer we expect, 5x to the fourth. All right, so that's the product rule. Derivative of the first times the second, derivative of the second times the first, add the two pieces together. And then you can do products of any functions. Now, if they're all powers like this, you could just simplify and use the power rule. But when we get into other types of functions, you can't always do that. Sometimes you do have to keep them as products. So now let's look at quotient. So a division of one function over the other. This rule is a lot more complex, and I'll say in practice, I rarely would use the quotient rule. I'll use something else called the chain rule much more frequently. Chain rule is a topic for next week. But let's learn what the quotient rule says first. It says if we're taking the derivative of f divided by g, then we have a numerator to work with and a denominator. And the denominator is easier. It's just that whatever's the denominator over here just gets squared. And then the numerator, it sort of looks like the product rule, except you're subtracting in the middle instead of adding. So we have the derivative of f times g and the derivative of g times f, which was just like the product rule, but instead of adding them together, we're subtracting them one from the other. So a bit more to remember here with the quotient rule than with the product rule. But let's take an example. Let's say we have this function j called j of x, and why is it called j? Little aside here. So we have f, g, the next one would be h, right? But we've used h in our definition of a derivative, let h go to 0. And I in math is the imaginary number, I, so generally off the table as a variable. So we're calling it j of x. And it has a numerator of 5x squared. That's going to be our f function. And a denominator of 4x plus 3, which is our g function. So following the rule, derivative of the first times the second. So derivative of this is going to be 10x, so 10x. And then we leave this function alone for now. It just stays 4x plus 3. Minus derivative of g. So this is a line. The 3 is differentiating 3 gives us 0. Remember, it's just a constant. And derivative of 4x is going to just be 4. So 4 here, and then times the f is 5x squared. And then the denominator through this whole thing, I'm just going to leave it as g of x, 4x plus 3 squared. So now, simplifying what's on top, I'll distribute through the 10x. So 10x times 4x gives me 40x squared. 10x times 3 gives me 30x. And then 4 times 5 gives me 20. So I have a 40x squared minus 20x squared. That's going to simplify to 20x squared. 30x stays 30x. And this is our answer for the derivative of this function. There may be other simplification we can do here. I haven't looked at this one much deeper, but this is essentially the answer. We have a formula now for the derivative of j using this quotient rule. All right, so last topic this week is to talk about derivatives of trigonometric functions, and then more derivative rules to come next week, and then we'll start thinking about applications.